Okay, so as I said, I felt it was going to stop, and so it did. So let's go ahead and continue with example 4. This is going to be our first medium level of multiplying polynomials. We did an easy one, so we're going to go ahead and now do a medium level. So let's go ahead and distribute. We're going to still use the FOIL concept. It's still going to be the same. This is where you have to remember your laws of exponents from Algebra 1. If you multiply like bases, you add the exponents. So that's all that we're going to remember from here. All right, so I'm going to use blue for this first term, x, and I'm going to multiply this x term into everything inside this trinomial here. So we have x times 3x squared, which is going to give us 3x cubed. Let's go over that for those that are confused. In front of this x is a number that you will call 1, right? Let's just worry about the numbers first. What is 1 times 3? 3. This is where this 3 is coming from here in blue. Then all we have left to do is to multiply the variables. Remember, when you multiply like bases, you add the exponents. This is an exponent of 2. This is an exponent of 1, even though you don't see it. 2 plus 1 is 3, so that's why you have 3x cubed. All right, so then we have this here. And what is 1x times negative 2x? Well, let's worry about the numbers first. What is 1 times a negative 2? A negative 2. And then let's look at the variables. This has an exponent of 1. This has an exponent of 1. They have like bases. So we can say like bases, you add the exponent, so you get squared, or a 2. And then you have 1x times a positive 4. Usually everyone knows how to multiply that one. You get a positive 4x. All right. We have done that term. Now we got to multiply this 3 term into everything inside this trinomial, just like what we did with the 1x. So here we go. 3 times 3x squared. This is a lot easier because this 3 doesn't have a variable. So it's going to be easier for y'all. It'll be 9x squared. 3 times a negative 2x is going to be a negative 6x. And then 3 times a positive 4 is going to be a positive 12. And then from there, you must remember your adding and subtracting rules for polynomials. So let's go ahead and start off with the highest exponent here that I see is cubic, or it's to the third power. Is there anything else? Nope. So we are just going to write it down again. And then from there we have a squared term. Do we have any other squared terms? Yes, we do right here. Color coding helps here. So this reads as negative 2 plus 9, and that's going to give us a positive 7x squared. From there we have the x term, so plus 4x, or a positive 4x, minus 6x, and that's going to give us a negative 2x. And then 12 is the only constant by itself, so we just bring it down. So our final answer for this one, when we multiplied it, is 3x cubed plus 7x squared minus 2x plus 12. Okay, now we are going to use go on to a difficult level one. And again, it's not so difficult. These are pretty simple. If you end up having me for pre-cal next year, I tend to go a little bit crazier and bigger with these multiplications. So this is baby stuff. I usually do something a lot harder than this. All right, so now let's say the next example, which is example 5, I believe. All right, example 5 says multiply x minus 5 times x plus 1 times x plus 3. Okay, this time you have three things that you're multiplying together. And like anything, let's say you had this right here. Let's say you had 2 times 3 times, let's say, 5. Okay, what would you get if you had this? 2 times 3 times 5. Can anyone tell me what you got? 30, right? There's a lot of different ways that you could have gotten this answer. You could have said 2 times 3 is 6, then 6 times 5 is 30. You could have said 2 times 5 is 10, and then times 3 is 30. You could have said 3 times 5 is 15, times 2 is 30. So either way, I always multiplied two things together, and then I multiplied that product of the two things, or the two terms, by the third term to get my final answer. That's the exact same concept that we are going to do here. So what I'm going to do is I'm just going to go ahead and multiply these two by using the FOIL process. So we have, and I may go a lot quicker this time, x times x, so we're going to get x squared, x times 1, and we get just a 1x, and then we're going to go ahead and do this part here. So negative 5 times x gives us a negative 5x, and then a negative 5 times 1 gives us a negative 5. Okay, from there, we're going to combine these two terms. Those are the only things we can combine. So we end up getting x squared, and 1x minus 5x is negative 4x minus 5. Okay, but then we must remember we're not done yet. We have to multiply it by that third binomial that we have left, which in this case is x plus 3. And again, we use the same FOIL concept. So here we go. We have to multiply each of these terms into these two terms in here. So we have x squared times x, and that's going to give me x cubed. And x squared times 3, and that's going to give me 3x squared. Different color. Now we have negative 4x times x, and that's going to be a negative 4x squared. And a negative 4x times 3, and that's going to be a negative 12x. Let me use a different color. A negative 5 times x, and that's going to be a negative 5x. And then a negative 5 times 3, and that's going to be a negative 15. All right, so then we go ahead and combine like terms. we have x cubed. It's my only cubic. Then let's move on to the squares. It looks like they're right next to each other. So it reads as 3 minus 4, which is going to be a negative 1 x squared. And then we move on to the x right next to each other. So it reads as negative 12 minus 5, and that's negative 17x. And then finally we're left with the minus 15. Okay, so we're left with, you don't need to actually write in that 1. I'm going to actually erase it because it bothers me. So your final answer is x cubed minus x squared minus 17x minus 15. Okay, I'm going to go over some special situations that you may have seen or may not have seen, but they are definitely popular in pre-cal and calculus if you get to that level. So we're going to go ahead and just go over those specific patterns. The first one is called a difference. I'm going to abbreviate difference of squares. And I'm going to show you with letters first, and then I'm going to do an example. So a difference of squares is something like this. Let's say you have two binomials, one that reads as a plus b, and the other one that reads a minus b. Okay, that pattern says that if you have something that's the same, and if you look at it, we realize that it's the same, right? The only difference is that one binomial has a plus sign and the other binomial has a minus sign. Well, if you have this difference of squares, then you can say that that is the same thing as a squared minus b squared. Okay, now let's take a look. Let's do an example. Let's say you had x plus 4 times x minus 4. And let's say you did not know this pattern of the difference of squares, but you do know, or you do remember the FOIL concept. So if you do the FOIL concept, you end up getting x squared negative 4x positive 4x, and then a negative 16. Okay, and then if we combine like terms, we notice that our two middle terms cancel out, so we're left with x squared minus 16. Okay, so in other words, with the difference of squares, your middle terms will always cancel out. So what I like to tell my students is that in reality, here is the shortcut. Let's do another one. X minus 5 times x plus 5. If you have a difference of squares pattern, really the shortcut is first times first, which is x squared, and last times last. So what's negative 5 times a positive 5? Negative 25. That's really what difference of squares is. If we go back to this one that we did, the FOIL way,